two papers, The Missing Jolt by Graham McQueen and Tony Zamboti, and The Destruction of the World Trade Center North Tower in Fundamental Physics by David Chandler, which are both found in the Journal of 9/11 Studies, make related arguments proving that the top section of the North Tower of the World Trade Center could not have crushed the lower section of the building. Some of the same arguments are presented in the video Downward Acceleration of the North Tower, which has been posted on YouTube. The conclusion of the Chandler paper is that since the top section of the building undergoes constant downward acceleration as it encounters the lower section of the building, the force it exerts on the lower section of the building must be less than its own weight, so it cannot possibly be crushing the lower section of the building. The conclusion of the Zamboti-McQueen paper is essentially the other side of the same coin. In order to crush the lower section of the building, the top section would have to actually impact the lower section, and in so doing it would experience a jolt which is not observed. When you hit a nail with a hammer, the impact drives the nail into the wood, but it also slows the hammerhead. In the case of the North Tower, this did not happen. NIST, the National Institute of Standards and Technology, assumes that the falling section of the North Tower acted as a pile driver to destroy the core structure of the lower section of the building. However, the observation that the top section accelerated constantly downward contradicts this claim. The clear implication of the physics is that the falling section of the building is not actually crushing the lower section. It is falling into the rubble as the lower section of the building is being destroyed by other forces. To check whether this analysis is correct, let's do the same measurements for a known demolition. The Balzac-Vitry demolition is particularly interesting for our purposes, because instead of using explosives, the columns on the middle floors of the building are collapsed using hydraulics. The only destructive force thereafter is the impact of the upper section on the lower section of the building. Therefore, we know that crushing, not explosives, is what is destroying the building. The question we want to answer here is whether the predicted deceleration of the falling section will show up in our measurements. To make the measurements, I'm using the program Tracker and placing marks on the roofline of the building at 0.2 second intervals to track its motion. From the data, we plot the velocity as a function of time. The slope of this kind of graph gives the acceleration. Deceleration means the downward velocity would be reduced, so the slope would have to turn around and actually rise left to right. If we look at the graph of velocity versus time, there is a downward slope at first. During this interval, the top section accelerates downward until the two sections collide. We can tell there is some resistance, because the downward acceleration is less than the acceleration of gravity. As the contact begins, the slope becomes less steep. However, when the two sections of the building fully engage, the slope of the graph turns around and actually rises, indicating that the downward velocity is decreasing. This is clear deceleration, just as we predicted. The graph of the Balzac-Vitry demolition is what one would also expect to see in the case of the North Tower of the World Trade Center, had the falling section been responsible for crushing the lower section of the building. The fact that the downward velocity continually increases tells us that the destruction we see is not due to crushing. Something other than gravitational collapse had to be at work to destroy the building. The Balzac-Vitry demolition illustrates another important conclusion. The impact destroys both sections of the building at the same time, which is why the demolition team initiated the process in the middle. This two-way destruction is a clear consequence of Newton's third law, which says that as bodies interact, the forces act equally in both directions. Had the top 12 floors of the North Tower actually crushed the lower section of the building, the falling block would have been destroyed by the same forces and at the same rate as the lower section, or even faster since the building was built progressively stronger at lower levels. At most, the top 12 floors might have destroyed an additional 12 floors, but the top section would have been consumed in the process, leaving nothing to crush the rest of the building.